All right. So let's look at this. What do we need to do first here? We need to find the common denominator, which means what do I need to do before I can do that? Factor. There's one piece in here that needs to be factored. This guy. So we're going to have our 2 over. What is that one in factored form? X minus 2, x plus 2. Because that is a difference of squares. So that piece has been subtracted. I'm going to give myself a little bit of space here. This one's just going to come down. And we're going to have our 3. Zooming this out a little bit. And I'm leaving a few spaces there. That was in a very strange space. There we go. So, what is our least common least common multiple so that we can find our denominators? X plus 2, x minus 2. That's a minus. So, feel like I'm going to work from right to left, which feels backwards, but the right ones are easier than the left one. So on this one, do we need to multiply anything to get to that common denominator? No. So this one's good to go. How about this one? What do we need to multiply by? The x minus 2. So we need to take the piece that it's missing, that x minus 2, and x minus 2. What about over here? Both pieces. It doesn't have either of those in the denominator. In order to add and subtract them together, we need to have them in the denominator. So we're going to take this one times both pieces. My x plus 2, x minus 2. X plus 2, x minus 2. So we're going to do the multiplication pieces here. Everything's in a common denominator, so we're going to be able to combine some things together, which is fantastic. I'm going to do them in separate fractions first, and then I'll combine together. So we do need to multiply it out. Since we're adding and subtracting, we're going to combine like terms. What's up?
For the 3, can you do like 3 times x squared minus 4?
Yeah, well, that's where we're going to wind up on this one. Yeah. So if you notice that, skip that step, that's totally fine. And multiply it out there. Because this is, like we just said, or we just noticed over here, that this is 3 times that difference of squares. It's that x squared minus 4. So what is my numerator going to be if we're fully simplified? 3x squared minus 12. And we're over that same common denominator, x plus 2, x minus 2. I'm going to keep my fractions separate for just a second, but you can smash together at this stage if you're ready for it, okay? So our middle piece, our denominator is still our x plus 2, x minus 2. We're going to leave it in factored form. What's my numerator going to be multiplied out? X squared minus 2x. I heard it. It was quiet, but it was there. And our last fraction we didn't need to do anything to, so it's already in its simplified form. X minus 2, x plus 2. Shboop. All right, so we're now going to make this one fraction. And if you can simplify it all in this step, that's 100% okay, or you can write it all into one line, whatever we need to do. So now we have that common denominator on all of our pieces, so we can make it into one fraction. And when we take our 3x squared minus 12 plus x squared minus 2x minus 2, and we combine our like terms, what do we get? Four x squared minus 2x minus 14. Is there anything we can do to simplify this? Yeah, the top has a numerator of 2, or has a GCF of 2. Good at thinking things. So we can try that and see if it'll let us simplify anything. So if you take out our GCF of 2, it's going to leave us with our 2x squared minus x minus 7 over x plus 2, x minus 2. Will our trinomial here factor? Can I keep going? No. It would be multiplying to negative 14, adding to negative 1. There is not a set of numbers that we can do that with, so we can't factor it here. So that is our simplified answer. There's nothing that can cancel out. There's nothing else we can do. This is where we stop. I'm going to zoom out to the whole thing because I know this one's a little bit long. But I am 90% sure that there's one with a whole number on the homework. Like this, where you'd have to multiply by everything in your denominator. Which is one of those things we just get a little stuck on sometimes. Questions on this one? We're going to go do one more kind of like this before we go into the last bit of this section. Okay? So it looks like this. And there's definitely some in the homework that look like this. It looks more complicated than it is. We have done all these things, I promise. I promise we have done all these things.
H over 1 times. Because if we flip it around, we just put in parentheses on the parity. Put it there. You know what I'm talking about? Like when you multiply, it's divided, you switch it, you multiply.
Because we've got this big old subtractive polynomial over h. So what we're doing is we're taking, ooh, that's not a pen. There we go. This piece and dividing it by h. So if it helps you, because we see these fractions and we go, take it out of this giant double fraction thing. Make it be our 4 over 3x plus 3h minus 1 minus 4 over 3x minus 1, and write it out this way, divided by h. It's absolutely fine to switch it around to make it not be a fraction. Also, by doing that, it helps us see we've got parentheses here, which means we need to simplify inside the parentheses before we do things outside the parentheses. So we're going to do the subtraction piece first, and then divide by h. So we're going to do the inside the parentheses. I'm so good at talking, guys. Oh my gosh. So we're going to zoom in on just this piece. Looking at our fractions here. Is there any factoring we can do? No. So what are we going to have our least common multiple for our denominator when I need a common denominator? We're going to have our 3x plus 3h minus 1. And what else is in a denominator? 3x plus u minus 1. We can't just do the first one because we can only do multiples. So it has to be multiplying. And the fact that there's an additional plus 3h, bless you, in there means we can't just do the first one. They have very similar pieces, but it's not exactly the same. So just like we did on the last one, we're going to multiply each of these fractions by the piece that they're missing. So I'm going to take my 4 over 3x plus 3h minus 1, and we're going to multiply it by the piece it's missing, that 3x minus 1 over 3x minus 1. And then we're going to subtract our 4 over 3x minus 1. And we need to multiply that by the piece that it's missing, which is the other one. Our 3x plus 3h minus 1 over 3x plus 3h minus 1. And this whole thing is still being divided by h. We're just not dealing with it right now. We're looking inside the parentheses first and dealing with that. So let's simplify these. Get this down into our one fraction. Our denominator is going to be this hot mess, our 3x plus 3h minus 1 times 3x minus 1. So we've got the common denominators. Now we need to do our distributions and simplify. You can do it in 2 steps, you can do it in 1 step, whatever works for your brain. So we're going to do our 4 times our 3x minus 1. It's going to give me the left-hand piece that is my 12x minus 4. And we are going to subtract everything from the right one. 4 times 3x plus 3h minus 1. So we're subtracting 12x plus 12h minus 4. And I'm still just going to put out here that divide by h because we'll deal with him later. Questions on any of these steps so far? When we simplify our what's inside the parentheses bit here, what do we get? Negative 12h is all that's left. And our denominator is exactly what we've been having before. Our 3x plus 3h minus 1, 3x minus 1. So now that we have it down into our one fraction, we're still dividing by h. But when we're doing fractions and dividing, what are we going to do? Multiplication by? Flip it, the reciprocal. So dividing by h is the same thing as times 1 over h, right? What's going to happen here? Look here. Can we simplify anything? The h. I've got negative 12h over h. The h's will cancel out. Only the pieces that are being multiplied can cancel. So we can't cancel any h's inside the parentheses, just the one that's outside. So our fully simplified answer is negative 12 over our hot mess denominator. 3x plus 3h minus 1 over 3x minus 1. What's that? You could multiply out the denominator, but you don't need to. It's just giving yourself extra work. We can always leave our denominators in factored form on these parts. Okay. Questions on these? They're gross, they're long, but they're a thing. Okay, because what we're going to be doing for the rest of this section is working with the rationalizing some more, kind of smashed together with this. I know. So, we've got kind of a definition-y thing here. We're going to be rationalizing using something called the conjugate, which is probably where you've heard it in English class, but not related to math. We may have heard it in foreign language because usually conjugate verbs. All right. So rationalizing deals with our roots because we don't leave roots in the denominator. And throughout this section, we're going to practice rationalizing the denominator, and we're going to practice rationalizing the numerator a little bit just because they like to throw weird questions at us sometimes. We will mostly, when we're using it for the rest of the year, mostly be working with rationalizing denominators, but we just follow instructions because sometimes they want us to do the numerator because reasons. But what we're doing here is we're trying to make it so that when we have our final answer, we don't have any radicals in the denominator. That's what we were doing before. We'd multiply by our square root over square root to make it look grosser but not have any radicals in the bottom. The problem when we have a binomial with radicals in it is if I just multiply by what it is, that square root of x plus square root of y, then it's going to still have radicals in it. So what the conjugate is, I think of it as the difference of squares, other half of this. So if I have square root of x plus square root of y, my conjugate is going to be the same terms, square root of x with the opposite sign, minus square root of y. We'll see why here in just a second. I know it's a little bit crazy right now. Again, we still can only multiply by 1, so we're going to put square root of x minus square root of y over itself. I have double parentheses there, and that one's trash. And what we're going to do is we're going to multiply these together. That's going to let us see why the heck we do this, because, oh my gosh, weird, gross. So we are going to multiply this one out in the denominator here. Our numerator is just 1 times that grossness. So it's just going to be our top, square root of x minus square root of y. And we're going to multiply out the bottom. I'm going to take my square root of x times square root of x. What's that going to give me? X. I'm going to take my square root of x times negative square root of y, which is negative square root of xy. We can multiply our radicands when our index is the same. I'm going to take my square root of y times my x to get plus square root of x times y. And then our last piece here is our square root of y times our square root of y. Oh, I do not like that red. It's too close to the pink. Sorry. Try the orange. Okay, that's better. Square root of y times minus square root of y is going to be minus y. The minus is outside the radical, so we can have the minus there. So square root of y times square root of y gives us just y, right? What do we see that's happening in the denominator here? Can I combine any like terms? Not the negatives. The two in the middle. They're the exact same thing, but with the opposite sign. So if I combine like terms here, what's going to happen to these two pieces? They cancel out. So we get square root of x minus square root of y over x minus y. And we officially have no more radicals in our denominator. That's the goal. No radicals in the denominator.
We can just leave it like that?
That's how we leave it.
Okay.
We are going to practice with this a bunch because the conjugate is weird to wrap our brain around. So this chunk is called the conjugate. This is what it is. That's the conjugate. It's the same terms, just difference of squares. So those middle pieces disappear. And we are going to practice with this a bunch. That's what the rest we do in a day. We're going to practice rationalizing denominators. We're going to practice rationalizing numerators. We don't work with it. Okay? So I know we've only done one, and they're weird, but questions as it sits right here. Okay. So here's another one. We're going to rationalize our denominator using the conjugate. So we're going for our denominator. What rationalize mean is make no more radicals in. So if our instructions say rationalize the denominator, what this means is no radicals in that piece. So we're having no radicals in the denominator is our goal. So I'm going to zoom it in on us. I've got square root of a plus 3 over square root of a minus 3. We are rationalizing our denominator, which means we look at this guy. We need to find our conjugate. The conjugate is always going to have the same terms. So we're going to have our square root of a and our 3, but it has the opposite sign. So it's going to have a plus. This is our conjugate. I'm just trying to make sure we're clear on what things are. This is the conjugate. And we want to multiply these pieces together, but I can only multiply if I have a 1 here. So we're going to put the exact same conjugate on top. Square root of a plus 3. I can only multiply by a 1. So do not try and match numerator. Like, just pick the denominator and go with that. Questions on the setup? Now that we've seen it once, at least once. Okay. So when we multiply these together, we are going to multiply out the top as well. What are we going to get in our denominator when we multiply these pieces together?
A minus 9.
We are. Because, again, difference of squares. So we know the middle two pieces are going to cancel out. So it's our square root of a squared, which is just a, minus 3 times positive 3, which gives us our minus 9. See how those pieces cancel? I don't know. They will, because if we multiply it out just like we did here, these middle pieces that come from these operations will always be exactly opposite. They will always cancel out if we do our conjugate right.
So we only have to multiply the first times the first and the last times the last?
Yes. As long as we set up our conjugate right, those middle terms will always cancel out. You can always write it out. Like, I'm going to write it out and then we'll jump down. So we'll do it together. So we got our a, square root of a times square root of a, which gives us our a. Then we've got our square root of a times 3. So 3 square root of a. That's my first term times both of the last. Then we have our minus 3 square root of a and minus 9. So that's our fully, no shortcuts, multiply it out. Which we can do the same thing with the numerator now, since we're up here. I'm going to have my square root of a times square root of a, giving us a. Square root of a times 3, giving us 3 square root of a. Now I'm taking my 3 times both terms, so we're going to have 3 times my square root of a. And 3 times 3, which is 9. So this is fully multiplied out. You do not have to hit this step if it doesn't help your brain. If it helps your brain, feel free to write it off. Okay? This is a fully skippable. If you can do it in your head, not everybody can. 100% valid. So now we're going to simplify everything. What do we have in our numerator? A. 6 square roots of a plus 9. What's in my denominator? A minus 9. Because these two pieces are exactly the same with the opposite sign, so when we add them together, they eliminate out. I'll make my 9s. I'll have a slightly longer tail because my A's are looking a little 9-y. Okay? We're aiming for a difference of squares so that those middle terms eliminate out. Questions? Because it's weird, and I get that. Okay. So, in the book, a lot of times, they're going to ask you to rationalize a numerator as well. Not ever on the same problem, because we can't rationalize both at the same time without magic happening. So we're going to rationalize the numerator. Remember, rationalize means no radicals in. So we want to have no radicals in the numerator. We're still going to use the conjugate. I'm just bringing us in so we can see it a little bit better. So we've got square root of a minus square root of b over a squared minus b squared. So we are told to rationalize our numerator. So that's going to be the piece we need to find the conjugate of. We're rationalizing our numerator per the instructions. I mean, you'll need triangles next semester, but you don't really need them right now. We're going to do so many triangles next semester. Like, you'll be happy with the number of triangles we have. All right. What's up? Not formal geometric proofs. Like, not the given with this, and the next step with that, and this with that. No.
I was so confused.
No. They take too long. All right. So, if we're looking at our numerator here, what is our conjugate?
No, wait, that was square root.
Looking at our numerator, square root of a plus the square root of b. It's the same pieces, but with the opposite sign. So then we're going to have our square root of a plus square root of b. We can only ever multiply by 1. Can't cancel out quite right now, because we don't have anything that matches exactly except for our 1. So then we're going to multiply things out. In my numerator is now where I have my difference of squares. So we're going to wind up with our square root of a times square root of a, giving us a. And again, we can write out the middle terms if we need to, as minus square root of ab plus the square root of ab, and then minus b. If that helps you, write that out. We are not going to multiply together our denominator pieces here. We're just going to hold them for just a second, okay? A squared minus b squared, square root of a plus square root of b. When we simplify our numerator, those middle two terms cancel out, and we're left with a minus b. A squared minus b squared, square root of a, square root of b. Okay. One last piece for us to see on this one, because usually it'll say rationalize and simplify. What do we notice is left here? Look in our denominator. Give me a clue. What do we have? Is there anything we'll be able to simplify?
Oh, we can
What's this?
A squared plus b squared.
That's a difference of squares. Factoring is still hanging out. That's a difference of squares. If we factor out that difference of squares, what are my factors for it? A plus b and a minus b. And then we still have our square root of a plus square root of b sitting over here. What's going to happen?
Cancel out.
They're going to cancel out. What's my numerator going to be left as? 1. So those cancel out. And our answer is going to be 1 over a plus b times our square root of a plus square root of b. And again, we do not need to multiply out our denominators. We want to factor them as much as we can, but we don't have to multiply them out. Okay? So that was our first numerator that we rationalized. And they're gross, but it's a thing, and we're going to have them come up fairly frequently. We are often told to rationalize our things. What's up? I'm going to talk about that in a minute. Okay. Fine. Breathe. All right. So we have 9 minutes left. There is another one up here to practice rationalizing the numerator. There's also a kind of problem in the homework that's weird. So I would like to do the weird like one unless you really want to do another rationalization right now.
We do the homework.
The one like on the homework, it's not that one. This one. There's some in the homework that say express as a sum of terms. Which we all get kind of like super stuck on. Like we look at this and we go, what in the Greek is that? It's not as complicated as we need it to be. But like we look at this and we say, I have no clue what to do. What they mean when they say a sum of terms is break it apart and write it with just exponents. We're not going to have fractions unless it's a number. So what I mean is I'm going to say we're going to take our 4x squared and put it over our x to the 2/3. And then we're going to subtract x over x to the 2/3. And then we're going to add 5 over x to the 2/3. Breaking it apart. I know it makes it worse for a hot second. I promise it'll get better on the next lines. Because what we're going to do now is we're going to go gross. Let's have them not be fractions. I want to combine these together. I want to get those x's out of the denominator. What can I do with my exponents in order to make them not be in the denominator? How can I simplify x squared over x to the anything? Subtract our exponents. Exponent loss. So this is really, and I'm going to do it in 2 steps, but you don't have to. This is really 4x to the 2 minus 2/3. Subtract our exponents. What is 2 minus 2/3? 4/3. Yeah. So that becomes 4x to the 4/3. So I'm kind of doing, bless you, doing this in a couple of steps. So this one, again, this is x to the first, and we're going to subtract our denominator. So this is x to the 1 minus 2/3. What is our simplified exponent here? X to the what? 1/3. Plus, how do I write this one? I don't have another x up here to subtract from. Negative 2/3, not minus x. 5 to the x of negative 2/3. The negative exponent is what puts it in the denominator. So it's taking the things we did with exponent laws and kicking it up to 11. Okay, this is what they mean when they say write it as a sum of terms. Okay, it's exponent laws and simplification smashed together. Sometimes it'll give you a problem that looks like this that is also really long. It's exponent laws. Write it out. Use your exponent laws and simplify it. What's up?
So that's the final answer?
That's your final answer.
That's it?
Yeah. I was saying we get really scared looking at it, but it's not super complicated. So I've already heard the question once. Homework 1.4 due tomorrow. We just finished talking about 1.4. I want to give you guys a chance to ask questions, so we're going to do the quiz on Friday. We're going to push the quiz back a day. I always reserve the right to push it back. I will never pull it forward. So we're going to do the quiz on Friday. That gives you a chance to finish up the homework, and if we got questions, to ask them tomorrow, okay? 1.4 and 1.3 is what's covered on that quiz. So it's our things like our adding and subtracting polynomials, factoring, multiplying things out, rationalization, and simplifying in the fraction stuff with our polynomials, okay? Those are the things that'll be on quiz 2.